Hi, Integrated Math 1. Welcome to Module 2, Topic 2, Lesson 3, where we are modeling linear inequalities. Yeah, so instead of having an equal sign in the middle, there are other things that are going to start appearing. It's nothing we can't handle. So we were just talking about Alan, right? And he was trying to raise money for his camping trip, and he was selling boxes of popcorn. And we had come up with this lovely function that he makes money selling boxes of popcorn, and it looked like 3.75b plus 25, because of course he was selling boxes of popcorn for $3.75 each. And of course they were all given a $25 credit toward that goal. So the graph shown represents the function that you wrote in the previous activity. So we wrote this lovely function, and here they gave us the graph. So nice of them to do that, right? So we're going to start doing all kinds of stuff with this graph. So let's suppose that Alan has a sales goal of $1,600, $1,600. So what I would like you to do is I would like you to draw a horizontal line. Remember, horizontal means flat. I'd like you to draw a horizontal line from the y-axis. Oh, I'm hitting things. From the y-axis until it intersects our graph function, to try to figure out where is the point that would represent $1,600 in total sales. Go ahead and hit pause. If we're going for 1,600, where's your horizontal line going to go? So go ahead and hit pause to work this out, and then hit play when you're ready to check. All right, so I drew my horizontal line at $1,600, and I just made sure I drew it long enough so that it would smack right into my lovely function here. That was important because this point is an important point, right? If we're trying to figure out how much he has to sell in order to make $1,600, that's an important point. So now that we've found this important point, can you look at the graph and figure out how many boxes would Alan have to sell to make $1,600 in total sales? And we'll talk about your thoughts on that. Go ahead and hit pause, see if you can figure this out from the graph, and hit play when you're ready to continue the discussion. So this is the point, right? And I know that's $1,600, but I want to know how many boxes. So I'm going to drop a line straight down to my x-axis, and it looks like we're counting by 60s here. So if that's 360 plus another 60, that would be 420. So it looks like Alan would have to sell 420 boxes of popcorn to make $1,600 in total sales. Of course, we can put our answer on a number line, right? We figured out he's got to sell 420 boxes. So let's use this number line. Let's say this number line represents the number of boxes sold if the total sales is equal to 1,600. So that means he would have to sell 420. So I would put a big fat circle, boom, right there on 420. I can put my answer on a number line. That's where the answer is, on the number line, right? Great. So this is all fine and good when things are equal to, but let's take this the next level, because this isn't about equations. This is about inequalities. So take a look. I would like you to analyze the region of the graph that lies below the horizontal line. So here's my horizontal line. I'd like you to take a look at this region below it. What does that region represent? Go ahead and hit pause, jot down your thoughts, and then hit play when you're ready to continue the discussion. So the region of the graph below that horizontal line, this chunk right here, represents the number of boxes that Alan would earn, Alan, I can phrase this right. The region of the graph below the horizontal line represents the number of boxes B that would earn Alan less than $1,600, right? This would be $1,600 exactly, but anything below that would earn him less than $1,600, wouldn't it? So let's write an inequality to represent that. So that means that my function f of b would have to be less than or equal to 1,600. But remember how we said that the answer, we made our little vertical line and we're like, oh, that's 420. So we could also say that in order for this to be true, that my number of boxes sold has to be less than or equal to 420. So I'm going to write b is less than or equal to 420. So either of these inequalities would represent this chunk that's down below the horizontal line. And now we can graph that on a number line. So here's my number line. It is talking about number of boxes sold. So I'm going to use the B one. The whole B is less than or equal to 420. I'm going to use that one since that is the number line that we're looking at. Well, I know that 420 is important, and so I'm going to put another circle there, a little dot right on my 420. But this says that B is less than 420. So all the less than stuff is going to be to our left. So I'm going to draw a big arrow coming all the way down to the left. And you just wrote the inequality on the number line. Check that out. Do all of these answers make sense though? Let's think about that for a moment. Do all of these answers make sense? So for D, do all of these solutions make sense in the context of the problem? We're talking about boxes of popcorn. So take a look at what you just drew on your inequality. Does that make sense in terms of boxes of popcorn? Go ahead and hit pause to jot down your thoughts and hit play when you're ready to keep the discussion going. It kind of doesn't. There are parts of it that cause some problems because only positive integers less than or equal to 420 make sense in the problem. And that sounds wordy, but here's what I'm saying. I'm saying Alan can't sell negative boxes of popcorn, right? And that arrow goes forever and ever to the left. Alan can't sell negative boxes of popcorn. I don't know what negative boxes of popcorn would look like. It's popcorn. That's always positive, right? And of course, Alan can't sell fractions of boxes of popcorn, right? He can't sell fractional boxes of popcorn. You sell a box of popcorn or you don't. You don't sell like a piece of a box of popcorn. Like that's weird. I don't even know how that would work. It's weird. So now that you've got the idea in your head of what we're dealing with, we're going to change it up a little bit. If we go to number 3 on page 124, we still have our graph here. I would like you to now analyze the region of the graph that lies above the horizontal line we drew. And it does not include my lovely point this time. So what I'd like you to do is I'd like you to answer questions A, B, C, and D. And then once you've done that, once you've worked that out, go ahead and hit pause and we'll keep the discussion going, guys. So we're now talking about the region above the graph, and we're not including that point anymore. So this represents, we're talking about the stuff above $1,600. This region of the graph represents all the number of boxes B that Alan would earn, that would earn Alan more than $1,600, right? I mean, if we're talking about above, this is when he's earning more than $1,600. So we can write a couple of inequalities to represent this. This means that my function f of b is no longer less than, it's now greater than. And notice how there's no equal sign anymore. Remember last time it was less than or equal to because it included the point? This one doesn't include the point now. It said not including the point. So now there's no squashed equal sign. It's just f of b is greater than 1,600. Or, of course, if we're just referring to the number of boxes, that means that b would have to be greater than 420. And so I'm going to use this second little guy to help me graph that. So now I'm going to use my little b is greater than 420. Now this time, because it's not included, I'm going to do what we call an open circle. So my circle is now empty. Do you see how I just drew a circle? It's not filled in anymore. That's because it doesn't include that 420. There's no squashed equal sign. The other difference is that B is greater than 420. It's the alligator eats the bigger one. B is bigger than that. So that means my arrow now goes to the right. And I'm sure you figured out what was going on with D. Do all the solutions make sense in the context of the problem? Not exactly, because again, only positive integers greater than 420 make sense in the problem situation. No fractions, right? Again, Alan cannot sell fractional boxes of popcorn. You sell a box of popcorn or you don't. You don't sell like, I'll give you the lid. Like, no, you don't sell pieces of boxes of popcorn. That's weird. All right, so can you take a moment? We talked a little bit about open and closed. Can you just explain to me, jot down your in your own words, explain the difference between the open and closed circles on our number lines. Go ahead and hit pause, jot down your thoughts on that, and then hit play when you're ready to keep the discussion going. So the open circle meant that the point was not included in the solution. So there was no squashed equal sign underneath our inequality. The point was not included, so it had to be open, empty circle. The closed circle, where it was actually colored in, means that the point is included in the solution. It had an equal to on it, and so we colored in our circle to give us that good, solid, closed circle. So now we're going to change it up. We keep playing with 1600, but here's what I would like you to do. I have several questions here for you to answer on number 5. I've got a bunch, not a bunch, but you know what I mean. I got a few parts for you to do. I got a few. So on number 5, I would like you to answer A, B, and C. Feel free to use the graph to help you do that. So go ahead and work that out and then hit play when you're ready to check your work for A, B, and C. So first of all, how many boxes would Alan have to sell to earn at least $925? So here's 800, here's 1,000. So I drew my horizontal line through here at roughly where 925 would be. It's not perfect, but I get the idea. And then I'm gonna go ahead and make my drop down and make my vertical line. Again, it's not perfect, but we get the idea. And it looks like my point is right about here. So that means it looks like Alan would have to sell at least 240 boxes. So to earn at least $925, Alan would have to sell at least 240 boxes. If you don't believe me, we can set this up as an equation. So remember how we said you could do f of b, and we're like at least. So if it's at least, that means more is good, less is bad. So I would say greater than or equal to 925. So my function needs to be greater than or equal to 925. But we know what the function is, right? We said at the very start of this that the function was 3.75b plus 25 is greater than or equal to, in this case, 925. And you can solve this just like you solve an equation. I want to get rid of the 25, so let's use the subtraction property to subtract 25 from both sides. Sorry, sound effects, I can't help myself. So I end up with 3.75b is greater than or equal to 900. And then I can get the b all alone, we're almost there, by dividing by 3.75. We do it to one side, you do it to the other. And lo and behold, b is greater than or equal to, oh, I need my calculator, 900 divided by 3.75 gives me, ooh, well, look at that. 240, that's exactly what we found earlier, isn't it? So yeah, the graph worked. This is some good stuff. I like that. Let me make it pretty. I'm about to prettify it. Are you ready? Let's make it all pretty. Alan would have to sell at least 240 boxes. At least. How'd you do on B? How many boxes would Alan have to sell to earn less than $2,050? So again, this is 1,800. It looks like we're counting by 200. So if that's 18, that would be 2,000, 20. So 1,800, that'd be 2,000. So just a little bit above that. So we like just the tiniest bit above it. And if you kind of extend this out a little bit, it hits right about here. So I'm going to drop a vertical line right on down there. Ooh. 480 plus 60, that's what, 540? I think so. So 480 plus 60, 540. So it looks like Alan would have to sell less than 540 boxes. But let's check the math, right? If I want my function to be less than $2,050, well, we said the function was $3.75 per box, and that they had a $25 credit, and it's got to be less than 2,050. So, all right, let's keep this party going. Subtract 25 from both sides, just like we did on the warm-up, right? Same trick. So I get 3.75 B's less than 2,025. And again, I'm going to divide by 3.75 on both sides. Use that division property to get it alone. I'm having issues writing. That's okay. And I'm grabbing my calculator. 2,025 divided by 3.75 gives me 540. Whoo, we're good. We're good. We've got math skills, people. Check us out. Again, I'm going to clear this up and we'll make it all pretty. That's so much prettier. So Alan would have to sell fewer than 540 boxes to make less than $2,050. Last one. How many boxes would Alan have to sell to earn exactly $700? Well, if that's 600 and that's 800, 700 is going to come right down the middle. It looks like it hits right about here. So I'm going to drop that line, 120 plus 60. That's what, 180? Yeah. And again, let's check with the math. My function B should equal exactly $700 because it's making 700 exactly. So that means I have 3.75B plus 25 equals 700. You know how to solve this. Do you even need me at this point to tell you to subtract 25 on both sides? I don't think you do, but hey, oh, look, my pen got mad. So I have 3.75B equals 675. You don't need me to tell you to divide to get the B all alone, to divide by 3.75 on both sides. You don't need me to tell you that. You know by now. You know. So I grab my calculator and I get 675 divided by 3.75 tells me, sure enough, 180 it is. So Alan would have to sell exactly 180 boxes in order, hang on, let me fix this. Exactly 180 boxes in order to earn exactly $700. Yay. All right. So now we're seeing that there's more than one way of doing this, that we can use the graph, but we can also write out the inequality to solve it. So another way to determine the solution set of any inequality is to solve it algebraically. So to solve an inequality means that you're going to determine the values of the variable that make the inequality true. Just like when we solve for an equation, you figured out what value you would have to plug in order for the variable to make the equation true. Same thing here. When you're solving an inequality, you're just figuring out the values of the variable that would make that inequality true. And so that means the objective when solving an inequality is similar to the objective when solving an equation. You want to isolate the variable on one side of the inequality symbol. You need to get your variable all alone on his own. Just how it goes. So to make the first deposit on the trip, Alan's total sales, F of B, need to be at least $1,100, at least $1,100. So you can set up an inequality and solve it to determine the number of boxes Alan needs to sell. So here we have Alan's work here. So he said, fine, the function should be greater than or equal to 1,100, just like we were doing before. We know the function is 3.75b plus 25, so we plug that in. And then just solved it the same way we solve our equations. So subtract 25 from both sides. That gives us 1,075 over here. And of course, I want my pen. And of course, that means those cancel out. Divide by 3.75 on both sides, so those cancel out. Now, unlike the problems we were doing earlier, this one didn't end up so pretty. We got B is greater than or equal to 286.6s, 6s, and 6s, and 6s, and 6s going forever and ever and ever. So here's the question now that we've done this work. How many boxes of popcorn does Alex need to sell to make the first deposit? Jot down your thoughts on that. And then hit play, hit pause to jot down your thoughts, and then hit play when you're ready to check your work. So I'm noticing that B needs to be greater than this 286.6666. So I don't want to round it down to 286 because that it needs to be bigger, not smaller. So that means since this needs to be bigger, I need to round this guy up to the nearest whole number. Remember, no fractional boxes of popcorn. So I'm going to round this up since B says greater than. So that means Alan needs to sell at least 287 boxes of popcorn. Alan can't sell partial boxes of popcorn, and if he sold 286 boxes, that would not be enough to earn him at least $1,100, $1,100. So guess we got to round that up to 287. All right. Let's take a look then at number 2. So now that we've done a couple of these problems, now that we just did another one there on number 1, I would like you to do number 2A and number 2B. For each of these, you need to write and solve an inequality for each. Make sure you show your work. So go ahead and hit pause, work out A and B, and then hit play when you're ready to check your work. Now, the tricky part on these is probably the setup, but here's the deal. Let's take a look. What is the greatest number of boxes Alan could sell and still not have made $600 in sales? So we don't want it to be equal to 600 because we're saying he's not getting there. That also means it can't be more than 600 because if he made more than 600, then he made $600, right? So I need my function to be less than $600. So I'm writing it out like this. My function should be less than 600. And I'm going to go ahead and plug in f of b is actually 3.75b plus 25. You know how this goes from here. Let me get my colors out. So subtract 25 from both sides. Again, do you even need me to tell you this anymore? I don't think so. But I've got 3.75b is now less than, what, 575? And that means we now need to divide by 3.75. And this is why we have calculators, because I'm not doing that in my head. Thank you very much. So if I do 575 divided by 3.75, that gives me 153.33, and they go forever and ever and ever. 3 is forever. 3. Ooh, but again, Alan can't sell fractional boxes. And notice that B needs to be less than that 153.333. So that means that when we round, we got to round down a little bit. when we do our rounding this time. So hang on, I'm going to erase this to make it pretty. This means that Alan could sell at most 153 boxes of popcorn and still not have made $600 in sales. Because again, no fractional boxes of popcorn, and now we want B to be smaller than this number, so we'll take it to 153. How'd you do with part B? At least how many boxes would Alan have to sell to make $1,500 in sales? So we want him to make $1,500 in sales. So more than 1,000, so equal to is good. We want to get $1,500. More than that would be good, right? Because if I more than $1,500, then I've clearly made $1,500. So that means I'm now going to set it up that my function f of b should be greater than or equal to 1,500. And again, I'm going to plug in for my function, 3.75b plus 25. And again, I'm going to go ahead and subtract 25 from both sides. So they cancel out. And again, I now have 3.75b is greater than or equal to 1,475. Once again, we must divide. Do you feel like you're doing a lot of the same thing over and over again? It's because you kind of are. So we'll divide both sides by 3.75. And again, I'm going to grab a calculator because I am not doing that mess in my head. So I get b must be greater than or equal to 393.333333 forever. Never. Okay, now again, can't sell fractional boxes of popcorn. And I want b to be bigger than this, so I'm going to round up because b needs to be bigger than this number. I'm going to round it up to 394. So that means Alan would have to sell at least 394 boxes of popcorn in order to make $1,500 in sales. Good job, Alan. Oh, we're almost done. Last but not least, we worked out that lovely example to show how we solved an inequality that was in the form of y equals ax plus b. The only thing is we're used to y equals ax plus b, but the example that we worked out had a lovely inequality in it, right? It didn't have an equal sign. How does your method change? How did solving it change when it had an inequality here instead of an equal sign? Go ahead and jot down your thoughts on that and then hit play when you're ready to check your work. So we're used to solving stuff with an equal sign, but you know what? We were just solving, oh, that's terrible. But we were just solving stuff that was like y is greater than or equal to ax plus b, or y is less than ax plus b. Was it really all that different when we solved it? Did any of our techniques change? I don't think they did. So because an inequality is solved the same way as an equation by using the properties of equality and the number properties, the method to solve an inequality doesn't change, even if it's written in a different form. We still solve them the same way. It's just how it goes. Be fair, man. Everybody gets it. That's how it goes. All right, guys. As always, I hope you found this helpful and I hope you found this useful. If you have questions or concerns, as always, please feel free to reach out to me, contact me, email me, come see me during office hours, stick around after class, ask me during class, talk to me. And I will see you guys later. Bye.